For interstellar exploration, conserving power is vital, especially for spacecraft like Voyager 2, which is over 20 billion kilometers from Earth. Recently, NASA engineers had to shut down one of Voyager 2's scientific instruments due to its diminishing power supply, as it continues to explore the vast region beyond our solar system. Launched on August 20th, 1977, Voyager 2 exited the solar system on November 5th, 2018. Today, it relies on 4 instruments to study interstellar space, which lies beyond the Sun's protective bubble, known as the heliosphere. NASA predicts Voyager 2 could run one of these instruments into the 2030s, but tough decisions must be made about which instruments to turn off as power runs low. Engineers have delayed these shutdowns as long as possible because Voyager 2, along with Voyager 1, remains one of the only active spacecraft studying this remote region of space, making their data incredibly valuable. One of Voyager 2's most important instruments, the Plasma Science Instrument, collects data using 4 specialized cups that measure plasma, a charged particle fluid flowing through space. 3 of these cups face the Sun, monitoring solar wind particles within the heliosphere, while the 4th is positioned to capture plasma in interstellar space and planetary magnetic fields. This instrument played a key role in confirming Voyager 2's crossing into interstellar space in 2018, detecting a significant drop in solar particles. Both Voyager 1 and Voyager 2 are powered by decaying plutonium, losing about 4 watts of power each year. During the 1980s, several instruments were already deactivated after the spacecraft completed their exploration of the giant planets in our solar system, which extended their operational lifespans. In recent years, they also shut down all non-essential instruments to conserve energy. Voyager 1's plasma instrument failed in 1980 and was later switched off in 2007 to preserve power. China has successfully launched a reusable satellite for space breeding and technological experiments from the Jiuquan Satellite Launch Center in the Gobi Desert. The mission, carried out using a Long March 2D rocket, placed various experiments into low Earth orbit. The Shanghai Academy of Spaceflight Technology confirmed the successful launch, identifying the payload as the Jiuquan 19 satellite, which was developed by the China Academy of Space Technology. This organization, part of China's main space contractor, is also working on a reusable crewed spacecraft designed for low Earth orbit, lunar, and deep space missions. The Jiuquan 19 mission is focused on space breeding experiments and includes plant seeds from various locations. Scientists hope that exposure to the radiation in low Earth orbit will induce mutations that could lead to benefits like shorter breeding cycles and other advantageous traits. The mission patch features a parachute, a returning capsule, and 3 rabbits, which may symbolize fertility and relate to the space breeding experiments. In China, space breeding is gaining importance as a method to enhance agricultural productivity, with space conditions expected to speed up genetic mutations that could improve crop resilience and output. Additionally, the Jiuquan 19 mission will conduct in-orbit tests to verify domestic components and raw materials and support the development of new space technologies. The reusable satellite will be used for these purposes, as well as for microgravity science and space life science experiments. The mission also includes payloads from 5 other countries, including Thailand and Pakistan, according to the China National Space Administration. This launch is part of China's expansive space program, which includes ambitious plans for deep space exploration, experiments on the Tiangong space station, and advancements in reusable space technologies. It was China's 46th launch of 2024, following the recent launch of 5 satellites aboard the 4th Jiuquan-1 solid rocket from Kias Space on September 24th. China has revealed its new spacesuit for astronauts set to walk on the Moon, with plans to land there by 2030. The unveiling took place during a ceremony where a technician demonstrated the suit, performing movements like climbing a ladder. China intends to use this suit for its crewed lunar missions by the end of the decade. The design of the moon landing spacesuit draws inspiration from traditional Chinese armor, giving it a strong and durable look. It also incorporates ribbons, a recurring feature in the design of Chinese spacesuits. This latest lunar suit is a refined version of the Phaetian suit, China's first homegrown spacesuit. Phaetian translates to flying in the sky and refers to a legendary Buddhist goddess. During the event, Yang Liwei, China's first astronaut and the deputy chief designer of the country's crewed space program, joined the technician to announce a public competition to name the new moon spacesuit. The campaign will run until October 31st, 2024. Experts offered further insights into the suit's lightweight and flexible design. According to CCTV, the spacesuit includes a highly protective fabric to guard against extreme lunar temperatures and dust, a panoramic visor that reduces glare for better visibility, 2 cameras on the helmet sides for video recording, a multifunctional control panel on the chest for more efficient operation. Astronomers have identified a planet orbiting Barnard's star, the nearest solitary star to the solar system. This exoplanet, named Barnard B, has about half the mass of Venus, making it a sub-Earth. It takes just over 3 Earth days to complete an orbit around its red dwarf host star, which is situated approximately 6 light-years away. Barnard B is located only 1.8 million miles from its star, a mere 5% of the distance between the Sun and Mercury. The planet was discovered by detecting the slight wobble it causes in Barnard's star as it orbits, exerting a gravitational pull. This was made possible using the espresso instrument, short for the Echelle spectrograph for rocky exoplanet and stable spectroscopic observations. The discovery was later confirmed using data from another exoplanet hunting tool, the High Accuracy Radial Velocity Planet Searcher, HARPS. Although Barnard's star isn't the closest star to our solar system, that title belongs to the Alpha Centauri system. It stands out because it is not part of a multi-star system, unlike Alpha Centauri's stars. Astronomers like González Hernández and his team have been studying the area around Barnard B, particularly searching for rocky planets in the habitable zone, also known as the Goldilocks zone. This region around a star has conditions that are just right for liquid water to exist without evaporating or freezing. In addition, the team has found promising indications of 3 more potential exoplanets around Barnard's star, which they hope to confirm using espresso.